Hi everybody, this video is on increasing and decreasing in function and using the first derivative test. Okay, so there's not many slides here. Let's take a quick look. To test if you have an increasing or decreasing function, we're going to look at the first derivative. And don't forget, when you take the derivative of something, it's also known as the slope. So when the slope is greater than zero, in other words, when the slope is positive, greater than zero, anything greater than zero is a positive number. When the slope is positive, you have an increasing function. Right? Here's a positive slope. And as you move from left to right, the function is increasing. If your slope is less than zero means it's a negative number. If your slope is negative, here's a line with a negative slope. It is a decreasing. It is a decreasing function. And if your slope is constant, if your slope is zero, horizontal line, if your slope is zero, horizontal lines have a zero slope, then your function is constant. It's not increasing or decreasing. Okay, and we can look at a parabola and show this. Here, if I move from left to right, my slope is decreasing. My slope is negative, this function, as I move from left to right, is decreasing. At this point, at this tangent line, my slope is constant. My slope is zero. So the function is constant at that point. And then my slope becomes positive here. My slope is greater than zero, it's positive. So it's increasing function. It's a very basic concept, but we do use it quite a bit in this chapter of calculus. Steps for finding an increasing or decreasing function. First, we're going to find the critical numbers. And you find the critical numbers by taking the derivative of the function and setting it equal to zero. Pick test values between the critical numbers. So we're going to pick some test values, and they're between all the critical numbers. And then take the first derivative test for those test values. Find f prime for the test values. And in other words, we want to find out if the slope is positive, negative, or zero. And then use the last slide, and it says the last slide, but I really meant previous slide. Use this previous slide to determine, if the slope is positive, the function is increasing. If the slope is negative, the function is decreasing. So use that slide to determine that. So here's the steps. It says, here's our function. Find the open interval that are increasing and decreasing. And this is without pulling it up on a calculator and graphing it. We can find this out. So step one, if we look at the previous slide, is find the critical numbers. So we're going to take the first derivative of this function. And the derivative of x to the third is 3x squared. And the derivative of this, we bring the 2 in front, and we subtract 1. The 2's cancel, and I get a minus 3x to the 1 power. 2 minus 1 equals 1. Okay, so I'm going to clean that up a little bit and just rewrite it so I don't have that mess up there. I get 3x squared minus 3x when I take the derivative of this function. All right, and we're going to set the derivative equal to 0. And solve for x. First, I'm going to factor out a 3x out of here. 3x equals 0. So if I divide by 3, x equals 0. Or x minus 1 equals 0. And if I take the 1 to the other side, I get x equals 1. These are my critical points, right? The critical points are when the first derivative equals 0. So I have a critical point at x equals 0 and a critical point at x equals 1. Now, if I look at a number line, here's 0, here's 1. Let's look at step 2. Pick test values between the critical numbers. It doesn't tell you this, but it says, let's read the instructions. It says, find open intervals. So I'm going to write the intervals that happen on both sides of these test values. Now, if we look at the entire interval, this on the number line starts at negative infinity and then it goes to 0, but it doesn't include 0, right? So on the other side of 0, it goes from 0 to 1. And then on the other side of 1, it goes from 1 to infinity. So I'm finding the intervals wrapped around these critical points that we found. So there's my intervals. Now, step 2 says find test values within these intervals. I'm going to choose a negative between 0 and negative infinity, or negative infinity and 0. I'm going to choose negative 1. Between 0 and 1, I'm going to choose 1/2. And between 1 and infinity, I'm going to pick something nice and easy. How about 2? And here is my function. Step 3 says plug the test values in. Step 3 says find the first derivative for the test values. So first I'm going to plug in this test value, negative 1, into this function. Three times x. So if I plug negative 1, my test value, in here, negative 1 squared is 1 times 3 is 3. Negative 3 times negative 1 is 3. So I end up with 3 plus 3 is 6. So the answer is 6, but I don't care about the answer. I just want to know the sign of it, and the sign of it is positive. The sign of the first derivative, when I plug negative 1 into it, is positive. Let's plug 1/2 into the next one, because that's my next test point. So I'm going to plug 1/2 in the first derivative. 3 times 1/2 squared minus 3 times 1/2. 1/2 squared is 1/4, so this is 3/4 minus 3/2. 3/2 is the same thing as 6/4. 3/4 minus 6/4 equals a negative 3/4. You see, once again, I found the answer, but I don't care about the answer. I just know the answer is negative. That's all we're really worried about. And finally, if I plug 2 into this function, 2 squared is 4. 4 times 3 is 12. Plug 2 into it. Negative 3 times 2 is 6. 12 minus 6 is 6. So I plugged the second test point in. I'm just going to try to do the work. 3 and plug 6 in there. Is that what? We're not plugging 6 in there. We're plugging 2 in there. 2 squared is 4. I end up with 12 minus 6, which is 6, a positive 6. And we get a positive answer. So the conclusion is, if our slope is positive, go to the previous slide. If our slope is positive, this means greater than 0 means positive. Our function's increasing. So our conclusion is, during this interval, negative infinity to 0, our slope is increasing. Negative means our slope is decreasing. And positive means our slope is increasing. So it's increasing. Sorry, it's a really messy. Maybe I should try to just clean that up a little bit. I'm just going to put it's an increasing slope function. It's a decreasing function. And here since that was positive, it's an increasing function. So what I'm going to do is put this in my calculator. I'm going to put the original function, x to the third minus 3 has 1.5 x squared I'm going to graph that. Let me set my window. Negative 5 to 5. It's kind of hard to see. I'm going to get it a little bit closer. Okay, so here's my function. And we said from negative infinity to 0. From negative infinity to 0, do you see how the function's increasing? From 0 to 1, here's 0, here's 1. From 0 to 1, the function's decreasing. And then from 1 to infinity, the function's increasing. So there's a graph. I typed in the function, and then I changed my window so we can see the picture better. And our function is definitely increasing until 0. Then it's decreasing until 1. Then it's increasing till infinity. Okay. Let's try the next problem. So the first derivative. Oh, so here's the actual first derivative test. The true meaning of the first derivative test. The first derivative test tells us if there is a relative minimum or a relative maximum. In other words, the first derivative test tells us if there is a valley, a low point, or a peak, a high point, right? A relative minimum or a relative maximum. If you take the first derivative and between the critical point, it goes from negative to positive, then you say it's a relative minimum. Do you see it? Our slope is going negative, then it goes positive. This is a relative minimum. From negative to positive, then at that critical point, we have a relative minimum. If our slope goes positive slope to negative slope, positive to negative, we have a maximum value. And if the slope is the same, there's no extrema. There's no maximum or minimum on both sides of the critical number. If it's positive slope to positive slope, then there's no valley or peak. There's no maximum or minimum. So let's take a look at this problem. First, I'm going to take the first derivative, find the critical numbers. First derivative of 1/2 x is 1/2, and the first derivative of sine x is cosine x. They want us to set the first derivative equal to 0 to find the critical numbers. Take the 1/2 to the other side and divide by -1, and I get 1/2 equals the cosine of x. So get your unit circle out. Don't forget. And on your unit circle, ooh, we're making it big. Look at that. Wow. We want to find out where the cosine equals 1/2. Cosine is the x value on your unit circle. Where is the cosine? Right there at pi over 3. I'm looking for another cosine of 1/2. Right there. And 5 pi over 3. So at pi over 3 and 5 pi over 3, the cosine is 1/2. Somebody remember that. Boy, I don't like it this big. So our critical points are pi over 3. Wait, let me put that up. Oh, I shouldn't have erased everything. Pi over 3 and 5 pi over 3. The first derivative was 1/2 minus cosine x, and then we solved and got 1/2 equals cosine x. And then we found these pi over 3 and 5 pi over 3. So the interval, oh, by the way, even though I didn't mention this in the problem, when they do trig functions like this, they wanted to keep our interval between 0 and 2 pi. And so we're not going from negative infinity to positive infinity. We're going to between 0 and 2 pi. So our first interval is 0 to pi over 3. Then we go from pi over 3 to 5 pi over 3. And then we're going from 5 pi, an interval from 5 pi over 3 to 2 pi. So I want to pick a point on my unit circle between 0 and pi over 3. It doesn't matter which one you pick. Between 0 and pi over 3, let's just pick pi over 6. And then I want to pick from here to here, and I'm going to pick pi, a test point pi, and then I'm going to go from here to there, and I might as well do 11 pi over 6. So I'm picking test points. One test point is pi over 6. The other test point is pi. And then the last test point is 11 pi over 6. let's see if I can remember that. So we said one test point was between here, pi over 6. Then between these two is just pi, which is 3 pi over 3, and that fits in there. And then we said 11 pi over 6. Okay, so those are the test points. So here's my function with the first derivative, and I have to plug these test points into it. So I'm going to plug these test points into there, 1/2 minus the cosine of x. Well, I'm going to go look now for the first, I'm looking for the cosine of pi over 6. On my unit circle, the cosine of pi over 6 is the square root of 3 over 2. Put the square root of 3 over 2 in here. And 3 is like 1 point something. So if I do 1 minus 1 point something, I end up with a positive number. And that's all that I'm looking for, is the sign when I plug that number into the first derivative is positive or negative. So the next one, I'm plugging in pi. The next test point is pi. Oh, I got to find the the cosine of pi. The cosine of pi equals -1. So I plug -1 into the function. 1/2 minus a -1 ends up being 3/2. Wait a minute. Let me back up just a little. I'm sorry. Did you see what I did? Did anybody catch my error? 1/2 minus more than 1. Do you see? I'm looking just at the top. Square root of 3 is more than 1. So if I do 1 minus the square root of 3, I end up with a negative number. I mean, you can put that on your calculator. 1/2 minus the square root of 3 over 2. You end up with a negative number. So the sign when you plug this in is negative. And the sign when you plug pi into it, pi ends up being, the cosine of pi ends up being a -1. And negative negative is a positive, so 1/2 plus 1 ends up being a positive answer. And once again, the cosine of 11 pi over 6, plugging 11 pi over 6 into here, you get 1/2 minus the square root of 3 over 2, which once again, that's a negative answer. So using our chart, between 0 and pi over 3, our function is decreasing. A positive sign for the first derivative says our function is increasing, using that chart that we had, that formula. And then if I get a negative when I plug in 11 pi over 6, my function is decreasing. Okay. And that's the first. Oh, well, we're not done. We know the function's increasing and decreasing and all that. But the first derivative test tells us if we have valleys and peaks. We haven't said anything. So our function goes from decreasing to increasing at this test point. So it goes from decreasing to increasing. If we go back, so we go from a negative slope to a positive slope, so I know I have a relative minimum. Do you see that it goes from negative slope to a positive slope? So I know this test point is a minimum, a relative minimum. And if we go from increasing to decreasing, these two are positive to negative slope. Let's look over here. Positive to negative slope, there is a relative maximum. At this, we have a relative maximum. And I'm actually going to plug this into the calculator for you so we can look at it and verify that our function is 1/2 x minus the sine of x. And our window is going to be from 0 to 2 pi. I'm putting about 6.5, so that's really close. So if we look at my graph, I guess I could do the window a little higher for the y values. There we go. So from 0 to pi over, oh, maybe that's too high. -5 to 5. So from 0 to pi over 3. Pi is 3.14. 3 is 3. 3.14 divided by 3 is about 1. Do you see from 0 to pi over 3, the function's decreasing, and then the function increases after that. So that is a relative minimum. Then the next we had, I don't know what we had next. I forget. The other test point was 5 pi over 3. 5 times 3 is 15. 15 divided by 3 is 5. So somewhere around the whole number 5 is the second test point. It goes from increasing to decreasing. So that should be a maximum. Let's check it out. Do you see somewhere 1, 2, 3, 4, 5? We have a relative maximum. It goes from increasing and then down to decreasing. So somewhere around 5, which is 5 pi over 3, we have a relative maximum. Here we had a relative minimum, and there we had the relative maximum, which were actually the minimum and maximum, not just the relative part. All right, that is the first derivative test. Don't forget, the first derivative test determines if you have a relative maximum or minimum, not whether the function is increasing or decreasing. You can use the first derivative to determine that, whether you have a positive or negative slope. But the first derivative test determines if you have a relative maximum or minimum at that critical number. I hope this video helps. Let me know. You guys have a great day.